everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of x cos alpha plus y sin alpha minus ct plus g of x cos alpha plus y sin alpha plus ct by eliminating f and g, which are arbitrary functions. So we are given a relation and we are asked to form a partial differential equation by eliminating this f and g, which are arbitrary functions. So let's see. And we have to notice that we have cos alpha, sin alpha, which can be treated as constants, and here c is also treated as constant, t is a variable. Okay, fine. Now coming to the problem, given z equal to f of x cos alpha plus y sin alpha minus ct plus g of x cos alpha plus y sin alpha plus ct. Consider as equation number 1. Now let's partially differentiate it with respect to x. Just apply dou by dou x on both sides of the equation. You'll get I did nothing. I just applied dou by dou x on both sides of 1. Okay, and this gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Okay, and also t is also treated as constant. Okay, so this gives us partial derivative of f of x cos alpha plus y sin alpha minus ct is f dash of x cos alpha plus y sin alpha minus ct into inner derivative, that is dou by dou x of x cos alpha plus y sin alpha minus ct. Okay, we can just skip this and write here we'll treat, here x is variable, right? Since we are partially differentiating with respect to x, so we'll treat y and t as constant, and also alpha, sin alpha, c are also treated as constant. So the inner derivative becomes partial derivative of x with respect to x is 1 into cos alpha is cos alpha. Okay, we can just skip it and write simply cos alpha. Instead of writing this, we can write directly cos alpha plus partial derivative of g with respect to x is g dash into inner derivative. Now this gives us dou z by dou x equal to f dash of x cos alpha plus y sin alpha minus ct into partial derivative of x with respect to x is 1 into constant cos alpha plus partial derivative of y sin alpha 0 minus partial derivative of ct is 0. Okay, plus g dash of x cos alpha plus y sin alpha plus ct into partial derivative, here just write, otherwise write cos alpha, which is constant, into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0. Right? This gives us dou z by dou x equal to 1 into cos alpha is cos alpha plus 0 minus 0 is cos alpha, right? Cos alpha into f dash is cos alpha f dash, that is cos alpha into f dash of x cos alpha plus y sin alpha minus ct, plus here also we'll get cos alpha into 1 is cos alpha plus 0 gives cos alpha into g dash is cos alpha g dash, you'll get cos alpha into g dash. Right? Now consider as equation number 2. Now let's partially differentiate it with respect to x. We'll partially differentiate 2 with respect to x, so that we'll get dou square z by dou x square. We'll find the second derivative of z with respect to x otherwise. Okay, second derivative of z with respect to x. Simple. And this becomes, let's do it. Partially differentiating 2 with respect to x. You'll get dou by dou x of dou z by dou x. You'll get second derivative here, okay? Equal to dou by dou x of cos alpha f dash. F dash is nothing but f dash of x cos alpha plus y sin alpha minus ct. Plus cos alpha into g dash. G dash is nothing but g dash of cos x cos alpha plus y sin alpha plus ct. Okay, this gives us dou square z by dou x square equal to cos alpha constant into partial derivative of f dash with respect to x is f double dash. Into inner derivative. Okay, that is dou by dou x of this term, this one, this 3. You can write inner derivative directly instead of doing this. Plus constant into partial derivative of g dash is g double dash. Into inner derivative dou by dou x of x cos alpha plus y sin alpha plus ct. Here we are partially differentiating with respect to x, so we'll treat y and t as constant, okay? And this gives us dou square z by dou x square equal to cos alpha into f double dash into partial derivative. Here you have x, right? And this is constant. These two are treated as constant. And here we have constant cos alpha. You'll write cos alpha into partial derivative of x with respect to x is 1, which gives us cos alpha plus partial derivative of a constant with respect to x is 0 minus partial derivative of a constant with respect to x is 0 plus cos alpha into g double dash into partial derivative. Here cos alpha is constant into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0. This gives us dou square z by dou x square equal to cos alpha into 1 cos alpha plus 0 minus 0 is cos alpha into cos alpha is cos square alpha into f double dash plus cos alpha into 1 is cos alpha plus 0 is cos alpha into cos alpha is cos square alpha. You'll get cos square alpha g double dash. Okay, so now we got the equation involving dou square z by dou x square. Here we will not use any notations, these notations, okay, because we have a variable t also. We'll be finding partial differentiation. Cos square alpha f double dash plus cos square alpha g double dash. Consider as equation number 3. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. We'll just apply dou by dou y on both sides of equation 1. Since we are partially differentiating with respect to y, so we'll write x and t as constant here. This gives us dou z by dou y equal to partial derivative of f with respect to y is f dash into inner derivative. Instead of writing dou by dou y of all these three terms, we can just write sine alpha, because partial derivative of y with respect to y is 1. 1 into constant sine alpha gives sine alpha, and partial derivative of x cos alpha with respect to alpha is 0, and partial derivative of ct with respect to y is 0. Okay, partial derivative of x cos alpha with respect to y is 0, partial derivative of ct with respect to y is 0, and partial derivative of y with respect to y is 1. So you'll get 1 into sine alpha, sine alpha. Simply you can write sine alpha, or if you are not that good at derivative, you can just write one more step. There is nothing wrong in it. Okay, plus partial derivative of g is g dash into inner derivative dou by dou y of x cos alpha plus y sin alpha plus ct. Okay, this gives us dou z by dou y equal to f dash of x cos alpha plus y sin alpha minus ct into partial derivative of x cos alpha with respect to y is 0 plus sin alpha into partial derivative of y with respect to y is 1. Since sin alpha is constant, so we are writing constant into partial derivative of y with respect to y, which is 1, minus partial derivative of constant 0, right, plus g dash into partial derivative of constant with respect to y is 0 plus partial derivative of y with respect to y is 1 into constant sin alpha. You can write like this also, plus partial derivative of ct with respect to y is 0. See, this sin alpha into 1 is nothing but constant into partial derivative of this y with respect to y, which is 1. Okay, fine. Now this gives us dou z by dou y equal to sin alpha. You can just close it with the brackets so that you won't get confused, right? Fine. Sin alpha into 1 is sin alpha plus 0 minus 0 is sin alpha. You'll get sin alpha into f dash here. One into sin alpha is sin alpha plus 0 is sin alpha into g dash gives sin alpha g dash. Right, consider it as equation number 4. So you got equation number 4, dou z by dou y equal to cos alpha, sorry, it's sin alpha, right? Sin alpha into f dash plus sin alpha into g dash is equation number 4. And notice that in equation 2 we have cos alpha f dash plus cos alpha g dash. You can write this as cos alpha of f dash plus g dash. You can just take cos alpha common, and here also you're having cos square alpha, cos square alpha, cos square alpha f dash plus cos square alpha g dash. We can take cos square alpha constant from these two terms so that you'll get cos square alpha of f double dash plus g double dash. And here also you're having sin alpha on both sides, on both the terms, so you can take sin alpha as common so that you'll get sin alpha of f dash plus g dash. Okay, why we are not taking here is because we need to find dou square z by dou y square. We need to find dou square z by dou y square, so that we'll just write this sin alpha like this. Okay, you don't take common now itself. If you want, you can take and do it, But for my convenience, in order to avoid mistakes, I'm not going to take sine alpha common here itself. We'll see that later. Now take this partially differentiate equation 4 with respect to y. Sine alpha f dash plus sine alpha g dash. This gives us dou square z by dou y square equal to constant into partial derivative. Here we are partially differentiating with respect to y, so we'll get x and t as constants. Okay, we'll get f double dash of x cos alpha plus y sine alpha minus ct into inner derivative dou by dou y of x cos alpha plus y sine alpha minus ct plus constant into partial derivative of g dash is g double dash x cos alpha plus y sine alpha plus plus ct into inner derivative dou by dou y of x cos alpha plus y sine alpha plus ct. It is easy, we just have number of terms, that's it. But cos alpha, sine alpha, t, c are constants. Okay, you don't need to worry about it. This gives us sine alpha into f double dash into inner derivative. Partial derivative of x cos alpha with respect to y is 0, since we are partially differentiating with respect to y. X is treated as constant, and also cos alpha, sine alpha and c are constants, right? Plus partial derivative of y with respect to y is 1 into constant sine alpha minus partial derivative of a constant with respect to y is 0 plus sine alpha into g double dash into partial derivative of x cos alpha with respect to y is 0 plus partial derivative of y with respect to y is 1 into sine alpha plus partial derivative of a constant with respect to y is 0. This gives us dou square z by dou y square equal to 1 into sine alpha, sine alpha plus 0 minus 0 gives sine alpha into sine alpha is sine square alpha. We'll get sine square alpha into f double dash plus 1 into sine alpha is sine alpha plus 0 is sine alpha into sine alpha is sine square alpha. You'll get sine square alpha into g double dash. Right? Consider as equation number 5. Now we need to find partial derivative of 1 with respect to t, and also we'll find second derivative of 1 with respect to t. Okay, let's see. Partially differentiating 1 with respect to t. This gives us dou z by dou t, and you can just write directly. Okay, see, every student cannot understand direct steps, so that I may need to write number of steps. But if you are really good at solving the problem without taking number of steps, just do directly. This gives us dou z by dou t equal to Here we are partially differentiating with respect to t, so we'll treat x and y as constant, and this gives us partial derivative of f with respect to t is f dash into inner derivative, that is dou by dou t of x cos alpha plus y sin alpha minus ct plus partial derivative of g with respect to t is g dash. G is nothing but g of x cos alpha plus y sin alpha plus ct, okay? The whole term. Into inner derivative. Dou by dou t of x cos alpha plus y sin alpha plus ct. This gives us dou z by dou t equal to f dash into partial derivative of x cos alpha with respect to t is 0. Since x is constant, cos alpha, sin alpha, t are constants, and y is also treated as constant here. So partial derivative of x cos alpha with respect to t is 0 plus partial derivative of constant with respect to t is 0 minus constant c into partial derivative of t with respect to t is 1 plus g dash of x cos alpha plus y sin alpha plus ct into inner derivative partial derivative of x cos alpha with respect to t is 0 plus partial derivative of y sin alpha with respect to t is 0 plus c into partial derivative of t with respect to t is 1. This gives us dou z by dou t equal to minus c, c into 1 is c. Here you have minus, so you will have minus c. 0 plus minus c gives minus c, you will get minus c f dash. Plus c into 1 c plus 0 is c into g dash is c g dash. Consider as equation number 6. Now let's partially differentiate equation 6 with respect to t so that you'll get second derivative of z with respect to t. Partially differentiating 6 with respect to t. Just apply dou by dou t on both sides of the equation, or you can just do directly. You'll get dou square z by dou t square equal to something. Okay, it's not necessary to write this, but in order to avoid mistakes, in order to make every student understand, I'm writing it again and again and again. Okay. Right? This gives us dou square z by dou t square equal to constant into partial derivative of f dash with respect to t is f double dash. Here we are partially differentiating with respect to t, so we'll treat x, y as constant, and also cos alpha, sin alpha, c is constants. Okay, we'll get partial derivative of x cos alpha with respect to t is 0. I'll write it. Plus constant c into partial derivative of g dash with respect to t is g double dash. Into inner derivative. This gives us dou square z by dou t square equal to minus c into f double dash of x cos alpha plus y sin alpha minus ct into partial derivative of x cos alpha with respect to t is 0 plus partial derivative of y sin alpha with respect to t is 0 minus c into partial derivative of t with respect to t is 1 plus c into g double dash g double dash is nothing but g double dash of x cos alpha plus y sin alpha plus ct into inner derivative. Partial derivative of x cos alpha with respect to t is 0 plus partial derivative of y sin alpha with respect to t is 0 plus c into partial derivative of t with respect to t is 1. Okay, this gives us dou square z by dou t square equal to c into 1 is c. We have minus c here. 0 plus 0 minus c is minus c. Minus c into minus c, minus into minus plus c into c, c square. We'll get c square f double dash. Right, plus c into 1 c, c into 0 0, c into 1 c, c plus 0, c plus 0 is c. C into c, c square. You'll get c square g double dash. Right. So this is our equation number 7. Now using all these equations 6 and 7, all the 7 equations, we'll find the required partial differential equation. Now we have equation 7, right? From 7, just take c square common, you'll get dou square z by dou t square equal to c square times f double dash plus g double dash. Right? Now bring this c square to LHS, you'll get 1 by c square into dou square z by dou t square equal to f double dash plus g double dash. Right? Or we can write from this equation, we can write f double dash plus g double dash equal to 1 by c square into dou square z by dou t square. We'll use this further. Consider as equation number 8 for our convenience. Okay. Now observe equation 3 and equation 5. We have cos square alpha f double dash plus cos square alpha g double dash, and here we have sin square alpha f double dash plus sin square alpha g double dash. Right? You can take cos square alpha common from this equation and sin square alpha common from this equation. If you add these two, we'll get sin square alpha plus cos square alpha of f double dash plus g double dash. We know that from trigonometric identity, sin square theta plus cos square theta equal to 1. So from this we'll get dou square z by dou x square plus dou square z by dou y square equal to f double dash plus g double dash. Okay, and that f double dash plus g double dash can be replaced using this. Let's see that also. So you can write equation 3 as dou square z by dou x square equal to cos square alpha of f double dash plus g double dash, right? Since cos square alpha exists in both the terms, right? And you can write this equation as dou square z by dou y square equal to sin square alpha, since sin square alpha is constant and it exists in both the terms, so you'll get sin square alpha common, sin square alpha of f double dash plus g double dash. Right? Now what we'll do is we'll just add these two. Then you'll get dou square z by dou x square plus dou square z by dou y square equal to cos square alpha of f double dash of x cos alpha plus y sin alpha minus ct plus g double dash of x cos alpha plus y sin alpha plus ct, right? Plus sin square alpha of f double dash of x cos alpha plus y sin alpha minus ct plus g double dash of x cos alpha plus y sin alpha plus ct, right? Now we can take f dash g dash common from these two terms. I mean this term, and from this term we can take f double dash plus g double dash common, so that you will get dou square z by dou x square plus dou square z by dou y square equal to f double dash of x cos alpha. First I will write cos square alpha plus sin square alpha into f double dash of x cos alpha plus y sin alpha minus ct plus g double dash of x cos alpha plus y sin alpha plus ct, right? We'll just take this term common from the two terms, so that you'll get cos square alpha plus sin square alpha of f double dash plus g double dash. We know that f double dash plus g double dash is 1 by c square into dou square z by dou t square, so this becomes, since sin square theta plus cos square theta equal to 1, right? So this becomes 1. Cos square alpha plus sin square alpha is nothing but sin square alpha plus cos square alpha, which is 1, right? Into, replace it by 1 by c square into dou square z by dou t square, since by 8. So finally you'll get dou square z by dou x square plus dou square z by dou y square equal to 1 by c square into dou square z by dou t square, which is the required partial differential equation. This completes the problem. So if you notice, we have f double dash plus g double dash in 1, 2, 3, 3 equations. You can think that we can just substitute in one equation and finish it off, like dou square z by dou y square equal to 1 by c square into dou square z by dou t square, but it's not possible. No, we can just not say not possible, but also we have one more equation, so that we have to think and do. Fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.